So they want us to use the limit definition of a derivative. Find the slope of the tangent line at any point A. Yeah, I guess they want everything in terms of A. Okay, so all you have to do is plug in A plus H into the function here. Plug in A in here. Oh, it's A equals 9. Okay, so that's even easier. So here, this is the definition. And so for the first term in the numerator here, for f of A plus H, we're doing negative 4 over 9 plus H. Because A is 9, and so we're plugging in this whole parentheses, the A plus H, in where X is supposed to go. So there, that is the first term. And we subtract that by what happens when you plug 9 into the function. So negative 4 over 9 minus 1. That's all being divided by H. So there's some algebra we can do to simplify. This is negative 4 over, and then down in the denominator you can do 9 minus 1 makes 8. This is again negative 4 over 8. So they don't have common denominators. Let me think what's easiest. I guess that's easiest is you got to get common denominators first. So I'm going to multiply the top and the bottom by 8 plus H. And I'm going to multiply the top and the bottom by 8. That way we have the same thing in the denominators. Okay, so if we do that, then we've got negative 4, and this is times. Negative 4 times 8 is negative 32. And then minus a negative 4, I'll change that to plus. 4 multiplied to 8 plus H in parentheses. That's all over 8. And then 8 plus H. Okay, that's what this part is, and it's still all being divided by H. So we can distribute in the top. We can distribute that 4. So it's negative 32 plus 4H. It's all over 8 plus H. And then this whole thing was being divided by H. So it's like a triple stack of fraction. But the negative 32 and the plus 32 cancel out. So we're left with 4H over 8 times 8 plus H. And we could say divide H in the bottom, or this is equivalent, right? You're dividing that fraction by H off to the side here. Okay? So writing it instead of like divide H in like a triple stack of fraction, we can write it like this, and that might make it a little more clear what we have to do. We could put this as a fraction, and if you're dividing two fractions, you flip and multiply the second fraction. So this is 4H over 8 plus H times 1 over H. So these H's cancel out. 4 over 8, that makes 1 over 2. So a simplified version is 1 over 2 times 8 plus H. And now we're ready to evaluate the limit. I dropped the limit notation everywhere. This is supposed to be the limit as H approaches 0. Limit as H approaches 0. Limit as H approaches 0. So the limit as H approaches 0, now we can find it. There's no more divide by 0 problem. You can plug in 0. 8 plus 0 is 8. 8 times 2 is 16. So this is 1 over 16. That's the slope at A equals 9. Find the equation of the tangent line. A line is y equals mx plus b, right? We've got our slope. Our slope is 1 over 16. So that goes in for m. And we just need to be able to plug in a point to find out what b is. It's the slope of the tangent line at x equals a, and a in this case is 9. So the point we have to use is 9 comma something. We got to find out what the corresponding y coordinate is. So you can plug in 9 into the original function. So 9 equals negative 4 over 9 minus 1. So negative 4 over 8, that's negative 1/2 when you simplify. So that's the point you can plug in to find out what b is. So I plug in negative 1/2 in for y. Plug in 9 in for x. So this is negative 1/2 over 9 over 16 plus b. So you can subtract 9/16 from both sides, and I'm going to turn this into a fraction with 16 as the denominator, so that's negative 8 over 16, and I'm subtracting 9 over 16 from both sides. So negative 8 minus 9 makes negative 17 over 16, so that's our y-intercept. Okay. So that completes the equation. It's y equals 1 over 16x minus 17 over 16 for a y-intercept.